for coming. We are OOOOOjOOOO broadcasting live from the ISDC conference in beautiful, sunny, smoggy Los Angeles, California. We have people in the room from Beijing, China. We have people in the room from what city in India? Louder and only one person. That's very difficult for me to pronounce. From India. We have people from Puerto Rico. We have people from Romania. Beautiful. And we have some folks from the United States of America.
LA.
I've heard of it before. Beautiful country. Beautiful. Nice animation. So today's topic is your future in space, visions of science and technology. And we have some very interesting people that are going to answer any of your smart questions today. And we're going to hopefully argue about what the future looks like. First, we have Eric and Eric Gever. Am I pronouncing it? Gever. Eric Gever. Eric works as a Boeing engineer. I'm not sure if I can talk about what his projects are, especially with Chinese people. But Eric is an expert in 3D printing and design. So if you look at this, for example, did you put this together on your machine?
Yeah, I built that on the printer. It's upside down. You got it right now.
This is it.
That's a SpaceX Dragon capsule, which Kiko over here works at SpaceX, but that's a vehicle that I print on my printer.
So we've been trying out, some of these guys have been trying out 3D design here at the conference for the first time. This is next level. Next level, when you go home, you'll be able to do that. So Eric will hopefully tell us a little bit about what he sees in the future for 3D design. Kiko, and I'm going to not pronounce your last name correctly, even though you told me just 10 minutes ago.
Dontchev.
Kiko Dontchev is an engineer at SpaceX, one of the most exciting companies in the world, except for Boeing, of course. And Kiko, what's your specific project that you're working on these days?
So I help lead the development of the crew program there. So we're taking this bad boy. Right now it just takes cargo, right? So any type of stuff, and we're making it able to take humans. So one of the lead engineers on basically getting this thing to be able to be a humanity spacecraft, so we can take humans to the space station.
So what does that mean? What's the difference between just the standard capsule, if we can call it a capsule with no people in it? What's the difference between the personless capsule and what you have?
There's two main upgrades to take our cargo capsule and make it something that we put humans in. The first thing is we have to add an environmental control system. So give and provide all of the things you need to exist in space. So oxygen, a toilet, food, water, be able to scrub the air for CO2 and things like that, recycle the air. Provide all of those elements that allow us to live on Earth, but provide them in space. The second thing is the addition of a launch abort system. So if for some reason the rocket were to explode, which if you guys didn't know, there was a Russian rocket yesterday that actually failed Proton. So that's kind of an example of these things do go wrong. If for some reason the rocket were going to go wrong, we need a way to make sure that the astronauts are safe. So anywhere, as soon as they get into the capsule, from the time that they come home, we have the ability to basically abort off the rocket, even if it's sitting on the pad, anywhere in ascent or in orbit, come home and make sure the astronauts get home safely. So those two things we need to add to Dragon to basically make it ready for.
So the leader of your company, the founder of your company, SpaceX, is particularly interested in Mars, right?
Correct.
So we'll be interested to come back and talk about Mars specifically in a second. Henning Roedel, and I'm pronouncing your last name correctly because I've actually had a chance to do so in public more than 0 times.
More than 0 times.
Henning is a construction engineering PhD candidate at Stanford University. You went to undergrad at UCLA, right?
Okay, go Bruins.
And you studied construction engineering for undergrad as well?
Yeah, I studied civil engineering more broadly, so anything to do with infrastructure here on Earth.
So you have something really awesome that I keep telling about 1 billion people about because it's one of the coolest technologies that I've seen. Tell everybody what this is and why a construction engineer is even talking about space.
Yeah, at a space conference nonetheless. This is a construction material, and this is a sample, and yeah, we can pass it around. It's lunar regular simulant, so it's moon dust, and it's held together with a protein. And the fun thing about proteins is that they can be grown. They can be broken down. And so the idea is that when Elon mentioned that he wanted to live on Mars or retire on Mars, I said to myself, well, you know, he's going to need someone who can build him his retirement condo. And why couldn't that be me? And so that kind of led down this path. And I ran into a group of crazy engineers at NASA Ames, and they had this project, and they said, you know, we need some construction experience, so we can make sure that we're not doing just some scientific experiment, but we're actually doing something that's practical. And yeah, it's a very exciting technology.
Why? Why do you need that? Why don't we just bring wood and steel rebar from the Earth to Mars or to the Moon?
That's a great question, Mark.
Thank you.
That's a very smart question.
Thank you.
And the reason why we don't do that is it's too expensive, right? You have to launch it there, and you're going to have to pay for all the fuel to launch it there. And once you launch your rocket, you have to throw it away. And so we believe in building with what is already there. So use the rocks that are there, and again with the proteins, you know, we'll engineer some microorganisms to produce the proteins. Let them consume the organics that are found in lunar water ice or Martian ice, and have them produce these complex compounds.
Awesome. So we'll continue. So let's just have this chat, okay? So these guys are all here. These guys all did a very interesting, fantastic job on the NASA space settlement competition, and they are probably going to participate in space somehow in their future. So why don't we start by talking about the path to Mars? So there's a number of technologies and breakthroughs that we have to do that we haven't accomplished yet. From my understanding, I don't think we can leave right now and get to Mars and set up a colony there and thrive there for, let's say, 10 years. Do we have that capability right now?
I would vouch that we actually do have that capability, but we definitely do not have the ability to get anybody home.
Okay.
So I think in everybody's lifetime here, we will go to Mars. I don't know if we will come home from Mars. I would actually put my money on the fact that when we go, we will definitely not come home. The biggest obstacle right now, in my mind, is money, because there's no business case for just sending people to Mars. Like, there's no money to be made, right? And everybody in the government and the private industry cares about making money, unfortunately. So that's kind of the biggest challenge we have to overcome. So if you can make a business case for going to Mars, then you really can start trying some stuff. So there's definitely ideas there. Obviously, like the fundamental thing is exploration and like pushing the boundaries of where humans have gone. But I think we absolutely have the capability to go today. We just can't do it cheap enough to make it feasible for us to go today.
What about space cancer? I heard that space cancer was a difficult thing. That was a challenge that the kids should be doing today as radiation glasses. When you leave the atmosphere and the magnetosphere, I think affects it as well, right? When you leave the atmosphere and magnetosphere of the Earth, you're no longer protected by a lot of radiation, and so you can get some pretty bad space cancer.
So I want to point
that, right?
Yeah, I'll point out that the International Space Station, we have astronauts that stay up there for, maybe a year even if they could. They can stay up longer if they wanted to. But the International Space Station is really not very high. It's only, 180 nautical miles above the Earth's surface. And that's still within what's called the Earth's magnetosphere. And it's the area where all of the radiation that comes from the sun is absorbed, still above them. And so they're pretty safe there. The problem is, the only time we've ever gone out, humans have only gone out of the magnetosphere is when we went to the moon, and only for a few days. And so it's not really well understood how well a human can survive, with that type of radiation environment. We do know ways to combat radiation. If you go to a doctor's office and they, zap you with X-rays and things like that, they give you a big lead plate to put in front of your heart to protect you. But you can't just, build your spacecraft out of a huge, thick piece of lead because it's way too heavy and it's not going to be efficient. There's just no way to do that, really. So it's an interesting problem, and it's definitely something that we're going to have to solve before we go to Mars. We're going to be spending up to 8 months or more to try to get there. And then once you're on Mars, Mars itself doesn't have a very large magnetic field, and so you're going to have to protect when you're there as well.
What are the other major things that we haven't checked off the list yet? If we want, you said you think that we have the technology to go there right now.
Yeah,
it's just a matter of money.
Yeah,
there's nothing that's blocking our path to do that besides money.
there are some. I think the environmental and societal impacts of isolation and understanding how the human body reacts and that we'll call it deep space atmosphere in our environment is definitely something we do not know enough about to have any idea of whether someone's going to survive. So I'm just saying that we have the ability today to put a human in a capsule and send them there. Whether they are alive when they get there or not is probably a question at hand. And so we can get them there.
Kiko made a great point before about the difficulty in getting back. Actually getting back from Mars to Earth is a really, really difficult problem to solve because only 10% or less of the mass that you're actually building into the rocket when you launch it is actually getting into space. And if you think about trying to build a really massive rocket on Mars to try to get back and you have to bring all your fuel with you, it's a really difficult challenge to solve. It's kind of like, I come up with an analogy of, let's say you want to take a day trip from here to Death Valley in the middle of the desert, and there's no gas stations on the way there. It's really easy just to fill your gas station up here in Los Angeles and drive to Death Valley, but if there's no gas stations to refill there, you're going to be stuck unless maybe you mine your own oil underneath Death Valley. Even on Earth, I would say that's easier to do than trying to make your own fuel from Mars and then trying to get back that way, and especially bringing all that with you.
So it sounds like there's, when we think about science and technology, that was the title of the presentation, title of the talk today, but it seems like there's a lot more difficult questions to be answered that are not even something an engineer is going to touch. Like, it seems like the questions that you're talking about are more about psychology.
Yeah, I mean, there is that aspect. I think Eric kind of got me thinking all of a sudden. I wasn't thinking before at all. But when you get there, right? So we might have a rocket today that can get this person in this small little capsule that can barely live, but you have a living, breathing person on Mars. But it's all the other things that you need to support it, right? And the science and research that goes into kind of what you're working on, taking the materials on Mars and actually making something out of it. Elon always talks about when we get to Mars, what are we going to do? And terraforming Mars, right? And if you guys don't know the word terraform, that means that you create an atmosphere somewhere to basically be able to create a livable habitat, which is his big dream is I'm going to ship 1 million people to Mars. I'm going to terraform that planet, and it's going to become another Earth. So giant machines that do not exist to create atmosphere will someday exist. And I think creating the habitable space there, that is something we have barely touched. So if the question is, can we send someone to Mars? Absolutely. If the question is, can we actually establish a permanent establishment there where people can live and reproduce and start a colony? There are so many questions fundamentally from the technology aspect that we have not even, yes. So some research has begun to broach.
Yeah, exactly. So that leads perfectly into what we're trying to do here. This is just the tip of the iceberg. This is the iceberg is synthetic biology. Is what I'm trying to say. I've been driving for 6 hours. I'm sorry. The tip of the iceberg is synthetic biology. What is synthetic biology? Well, think of computer programming. You write a piece of code and you hit run, and all of a sudden a screen pops up and your program runs. It says hello world or whatever. Well, we're trying to accomplish that, but with life, with biology. So instead of zeros and ones, we're trying to program A's, T's, C's, and G's. This is the code for DNA. So that you can send your software program to Mars, the moon, wherever, and you can have a microorganism start producing a biopolymer, a protein, so that can clean your water, it can recycle your waste, it can grow your food, it can clean your air.
So this is not 3D printing, this is bioprinting.
This is biology. This is your terraforming. This is your this is you're taking a little bit of Mother Earth with you, because we do that anyways. Right? We're an ecosystem of microorganisms, and so if we can, I don't know, change what's happening in our gut, make it a little bit more efficient, get us the nutrients we want, or more nutrients, then maybe we can overcome some of these big problems.
Space yogurt. You're talking about space yogurt.
Talking about
So
space
I'm going to
yogurt.
switch here. So we have this. Okay. So what I want to know is these guys are you guys are what, like 15 or 16 or 17 or something like that, right? So what I want to ask is when these guys are 44, 30 years from now, 40 years from now, when these guys are doing cool space stuff, what's going on the moon? Are they on the moon? Are they living in a building that's made out of this? What's on the moon in 30 or 40 years? What do you guys think?
There's two major ways you can go with this. It really kind of depends on. There's a lot of politics that unfortunately get mixed in with space exploration, and it's kind of a shame, because the space exploration they were doing when we went to the moon back in the 60s was not driven by a human desire to necessarily go there. It was driven more by the politics of can the U.S. beat the Russians, right? And you have to find that certain drive. So when I said there's two ways to go, can we find that drive? Does it have to be necessarily directed by another country challenging us to do so? If that drive can be found in some way, then I do believe in 30 years, at the very least, we would be able to get manned missions to, say, asteroids nearby. Potentially Mars on one-way trips. Maybe the moon if there was a justification for going there. It really depends on the human drive to actually want to do those things. Not necessarily because it would be financially profitable or necessarily because another country's doing it, therefore we have to also, but because we really want to learn about what it's like to live on a different environment from Earth and get there. So in 30 years, can I see one of you up there working on the moon, working on Mars? I can see it happening, but we have to start today, right? We have to get things started and have folks interested in learning about the math and science, driven by their own passion to get there, and it will take a long time, but we have to get started now.
So what do you think is a way? Your point earlier was that we're not really going to spend all the money to go to Mars unless we can make money by going to Mars somehow, right? Yeah. So how can we make money from being on the moon? What would be a scenario for making money from being on the moon? Yes, sir.
I know this answer. Water. Water is the currency of space. If you can get your hands on water in space, then you have a lot of power. People want water. Water can be broken down into oxygen and hydrogen. It's a rocket fuel. Oxygen is what we use to breathe, to catalyze our reactions in our body. Water is what we drink, and water is what we need for this. And there is a lot of water on the moon.
So if I go to the moon and start making water, I'm selling you water. I have
You're mining
I'm
water.
like a lemonade stand, but with water on the moon, much more expensive than 5 cents.
Yeah.
Who am I selling to? Who's my customer? Who's coming by buying water from me if I'm sitting on the moon?
40 years from now, hopefully it'll be more than just Russia or Roscosmos and NASA and the Chinese space program. But hopefully it's people like SpaceX, companies like Boeing, companies that don't even exist yet, Virgin Galactic, but Virgin Lunar, Virgin. But essentially, you sell them. This is your gas station at the moon. Right? It's going to take a long time. There is no infrastructure right now. You have to get there. You have to land there. You have to survive all of that. Then you have to last there for a long time. You have to mine this ice, which is trapped in a very dark and cold place. It's not easy to get to. So these are all challenges that have to be overcome. But once we can get there, and once that happens, and we can mine it, and we can start selling it to people, it's a lot cheaper than sending the water from
Here's a switching gears from the let's try to make money from doing something situation. Let's think about what might be possible and fundable by a NASA or by a Roscosmos or by the Chinese Space Agency or whatever. During the next 30 years, what is the most interesting science mission you think these guys will be working on?
Does it have to be science? Or does it just be technology?
Whatever, go for it.
So here's what it comes down to. Until we figure out how to lower the cost of access to space by 2 to 3 orders of magnitude. So that means right now, for example, a Falcon 9 costs $60 million.
60.
60. Okay. For one launch. To lower it. Until either that one rocket can do that 1,000 times for the same cost, or the cost of building the rocket is literally $600,000. Nothing is possible. Nothing. We're barely going to get off the ground. So my biggest hope is that 30 years from now, we can launch and land rockets just like the way we do airplanes. If we're doing that, the going and establishing a permanent base on Mars is absolutely 100% like within our reach. Without that, we're not going anywhere. My biggest takeaway to tell anybody I talk to that's young and interested in getting in aerospace is that every single person needs to think about reusability. It's like the most important thing in my mind. How do you make everything you do in your everyday life reusable? How do you make it more efficient, and how do you use it over and over and over again? Obviously, that applies at the system level, but it also applies at the smaller component part usage. So I think everybody needs to be fundamentally working on a problem at all times. We're driving this Earth into the ground. That is for sure with the way we're using materials. If we don't focus on that problem, we're soon not going to have anywhere to go and nowhere to get there and no way to get to anywhere we need to go. So that's my hope, is that when you guys are older, that rockets are just like airplanes, and you go to the spaceport and you get on a rocket and it takes off and it takes you to Earth orbit, and then that's like our game plan point. If we want to go to the moon or Mars from there, or we want to do something else or an asteroid, we go from there, because and then the rocket comes home. It goes through its technician comes out, and he's got a little clipboard, and he checks the clipboard things. They hook up the locks and the kerosene fuel, exactly. They fuel it up, and it gets going again. So, I mean, really, we're really going to be grounded, and the pace at which we can actually innovate is going to be dramatically reduced unless we figure out that problem.
Sure. Yeah, I was going to add one more thing about saving our planet and all that fun stuff. The only thing that we know that lasts beyond time, that has lasted throughout all of what we know, is Mother Nature. She's been able to figure out from the very get-go how to play around with atoms, and she's come up with this great system for manufacturing building blocks, proteins. And you can break it down into those very basic parts, and you can build it back up again. And that's the coolest thing. And if we can start to play around with that, start to experiment with that, I think we can win out. I also want to point out that these proteins can be recaptured too. This will dissolve in water, so it doesn't really work well on Earth right now. You get a rainstorm, your building's going to collapse on you. On Moon and Mars, that's okay. And it's even better, right? Because you dissolve this back into water, and you get the proteins back, and you can reuse them for the next application. So we're already starting to think about reusability, and it's very important.
So I am tired of asking questions, and I want to hear questions from some students. And oh gosh, what's this? It looks like a SpaceX pen. I guess whoever asked the first question is going to get the SpaceX pen. Yes, please come collect your pen.
The question? Yeah. The question for you. You said that, you said that in 30 years there will be probably a new technology, so we can travel to space many times. I think that the answer for that is space elevator. What did you think about it?
So the question was, what do you think about the space elevator? And maybe you should touch on exactly what that is.
Yeah, so does everybody know what a space elevator concept is here? So
everybody knows?
Okay. Smart guy.
For some reason you're not speaking up. It's pretty basic. It's you put something in orbit and you have a certain altitude, so it's rotating at the same speed as Earth. And then you have a ribbon that goes between Earth and said object, and you basically use it like a little elevator. You use lasers to power a vehicle to basically go up to said station. So it's like a quick way. You don't need rocket fuel. You just use concentrated light beam energy.
Do you think that the space elevator is maybe cheaper than just to launch a rocket?
Right now, the space elevator is definitely not cheaper because it doesn't exist. We have rockets.
Will be.
Will be though.
If it exists, I think so.
Yeah, I think there's some fundamental physics problems that need to get resolved in order to pull something of this off. I believe I'm not like too smart on the space elevator problem.
Well,
I think
so the space elevator works at a very specific altitude, right? The space elevator has to work at geo.
Yeah.
There's a lot of different orbits that you might want to use for various purposes, and in fact, a lot of them are used in low Earth orbit. The problem with you can't just like stop halfway up and get out and just be there in low Earth orbit because the velocity is different. You have to have more of what's called a tangential velocity, or a velocity kind of tangential to Earth to ensure that you stay in that position. Continue to go up. GEO is a very popular orbit. It's incredibly important for communications, that kind of thing. Just getting to GEO by itself won't help you get out of Earth's orbit and get to, say, the Moon and Mars. You still need a form of propellant to get there. So for the specific application of getting something to geostationary orbit, I think it's a good idea if the infrastructure was in place. But nothing else.
There's a question way in the back. Is your question that you can't hear us because we're not using a microphone, or do you have a real question? Sure.
Go ahead.
Wait. So about what you said about space elevators not being useful for launching to the moon or into deep space, if there is not a counterweight on the far end of the space elevator, and instead you just extend the tether, then you could just let the climber accelerate and then launch off into deep space, or wherever you wanted it to go. What do you think of that alternative?
Well, I mean, I think there's basically a sort of physics conundrum here in that for every action there's an equal and opposite reaction. So if you're going to be trying to, space elevator is stable because you have this centrifugal acceleration that counterweight that's keeping the space elevator intact as you're spinning. As you have an object climbing up that space elevator, it's trying to pull up against that counterweight. And that's okay when you have a very, very small mass of that you're using. But if you try to pull very, very fast, or you try to pull something that's very, very heavy, you're going to have a problem. You're going to almost end up pulling that counterweight out of its current orbit. So it's an energy transfer problem that you would then have to solve with the same type of rockets and other systems that we're using today. So I don't know if you have any comments. Please, as long as the center of mass is that you go.
So it's an engineering problem where anything below geo is going to want to fall back, and everything above it is going to want to fall away. And so as long as your center of mass of the entire system remains there, everything is just going to balance out. And so then having the counterweight above geo will be your balancing force, strong force.
How much mass is that?
It's a lot of mass. And the other thing too is you need to have a material that's strong enough that can withstand, its entire weight being pulled down by gravity, matched by double essentially, because it's being pulled.
We're giving out pens like crazy over here. Question number 3.
Yeah, you were talking about colonizing Mars. Suppose Martian life exists. There's actually aliens on Mars. What's going to be an approach? Like when we get there, we can't just confront them, right? We've got to have future planning. What's going to be our approach with Martian life if it does exist?
It's an awesome question. It's a really cool question. I think we need politicians. I hate to say it.
But not like actual, like the ones we have at Earth. We need like you guys to be the politicians. That's an incredible question. It's probably one we do not think about enough.
Here's the thing. When NASA sends a probe to Mars, like the Curiosity rover that just sent, they have to really make sure that whatever they're sending isn't contaminated with anything from Earth, viruses, bacteria that can potentially survive that trip. Because doing so could actually harm whatever life would be on Mars if you found it there. So I think the most important thing when we get there is to not immediately infest them with all of our bacteria that could potentially hurt them or damage them. But more importantly, be able to identify that whatever, if it's just microbial life we're looking for, bacterial life, is that this is from Mars. It's not just from Earth and then somehow it survived the trip and propagated over there. We have to, just be careful to desanitize ourselves, understand that there's going to be some level of separation at first, and then eventually try to merge ourselves in a way that it's not going to harm us or them.
If we were to discover life, like proper living beings somewhere else, it would change everything. I mean, the way we did everything. I cannot speak to the fact that society as we know it would be different forever. There is no hands down, or there's no way that it would be the same. It'd be such a radical shift in everything we've ever realized as human beings, especially if we get to learn and interact with said other being. My brain almost can't even fathom the idea. But not that I don't believe that there's other life on there, but fathoming the idea of us actually meeting some other being and how I would even react to that. Other than with just pure being frozen in time and not realizing this is real. Which is P.S. If you guys all think, or if anybody asks you, you think the Martians landed here and the government is just hiding it, there is absolutely no way we'd ever be able to keep that secret ever. So there's no way.
For the record, Area 51 exists.
Yeah.
Okay, it's an air base in Nevada, right? It's called Groom Lake. It's a place where they tested various things such as the B-2 bomber, SR-71 vehicle. They test a lot of vehicles there. That's the reason it was a secret base. A lot of this has been declassified now, so we all kind of know what was there. There was no discussion at all, even to begin with, where you wanted aliens. I believe that a rumor came from Roswell, New Mexico, which is a different story altogether. People like to come up with fun stories to persuade others about various things, or maybe sell books and movies and stuff like that. But I agree with Kiko. There would be no way to keep that secret. It would be way too difficult, and it's not even worth doing so, because why hide something for so long and when you can embrace that?
Who's got the next question?
I've got one more.
No. We'll come back to you. We'll come back. Go ahead.
Now we talk about the proteins in for the construction material. And is that microorganisms gonna to be survive in the space? And I mean, for example, is the DNA gonna be stable in such a condition?
Yeah. So that's one of the challenges we definitely face. I mean, radiation. I don't know if you know. You go out into the sun, you get a suntan. I mean, those are chemical changes happening because of just some of the lower forms of solar energy. So yes, and we are looking into that. So one of the laboratories in our group has come up with a design for a microorganism that can, we call it space hardening microorganism. And yeah, heat tolerances, so extreme hot, extreme cold, and then radiation resistance as well. So there's a protein that captures free radicals, essentially, free electrons. That will stabilize things. But will it really survive in space? We actually don't know right now. So there are some experiments being planned for plants, just your normal grass type of plant, and just send it to the moon and see if it'll grow.
Is everybody hearing okay in the back? No problems? Okay, we'll keep not using microphone. You're almost next. You're next.
Okay, so many of us are space settlement design contest participants, and we will design space settlements. How does our research, our participation in this affect scientific advances in the future?
Depends on what you do. So,
Yeah, you're exactly right. It's one thing to come up with ideas and design, what you think would be your ideal situation in space. It's another to go out and actually do that, right? And so it's the folks who, try to go actually make that happen that really counts here. And I did see a lot of projects downstairs, and a lot of them are really impressive and really cool things to come up with. But you can't just stop there and say, hey, I'm done. I came up with this really cool looking picture of what I think it's like to be in space. You have to go out and start making things, right? Come up with how, step by step, am I going to take this idea here and assemble it into this other structure here and put everything together, assemble it, and make sure it actually works. That in itself is probably the bigger of the two challenges, in my opinion, and the reason why you don't see them today is because no one took that extra step that all of you can do. I believe in all of you to do so, to go out there and take that design on paper and make it a reality.
Yeah. Ideas are free, execution is not.
Who's next? You need?
Yeah, as you said, there's a lot of water on the moon, but do we have a solution how to get it and purify it?
Well, we have solutions to purify it, but getting it is really difficult. So most of the water, the lunar ice we found, is ice, and it's located in craters that are on the poles of the moon. And so if you think about it, the sun's rays don't really pass through the craters at the north and south poles. And so they're kind of trapped in permanently dark places. And the temperatures there are really, really, really cold. And really cold. And so it's tough to actually get there. A lot of the materials that we have to work with today, they'll freeze up, they'll lock up, the mechanical, electrical systems might freeze up. So there are ideas of, taking, if you stand on the rim of the crater, you will get sunlight. So maybe collecting that and taking it into a beam, starting to melt some of the ice, and we can draw it up somehow. To trying to come up with a really cool rover that can survive those temperatures, but it's not going to be easy.
Who's next? Next question. Man in the red.
Is it possible to find another field in Mars to for the spaceship come back to the Earth?
Absolutely. So I think there's a lot of research going on that I actually can't speak to. Maybe you have any idea, either of you guys have any idea, but I think that's one of the fundamental things we're looking at is how can you take the materials on Mars or the moon for that matter and make them useful. And the biggest thing is on Mars is how do you take the materials and turn them into fuel.
That's the key. You have to use the resources that you have available local to you, right? And so what resources are available on Mars? Well, you have the soil and things like that that could have water underneath. I think it was said earlier that water is probably the most precious commodity. That's because water is not just used for drinking. You can use water to make fuel, propellant, through electrolysis, for example. So if there's water, there's a way, in my opinion. And coming back from Mars, using materials that you develop there, if, for example, you landed with an empty spacecraft, nice lightweight empty spacecraft, and then use water on board to create your propellants, your hydrogen and oxygen, found a way to distill it and compress it, get it into a state where you can actually use it as fuel. In my opinion, that's the best way to do it, and probably the only way.
I was going to say, I think it's the only way we're coming home is if we figure out how to mine what we're doing on Mars.
The only other way I can think of to do it is to create an assembly line approach where basically you have rockets going back and forth. Well, to start, just going forth. Constantly, right? Every day you're sending a new rocket to Mars, and you're constantly just dumping tons and tons of supplies. And as I said before, only about 10% of what you're actually putting into space actually stays there because you're using all the rest is basically propellant that you're expelling on Earth. But with enough propellant, I suppose, eventually you'll have enough resources on the planet just from bombardment of supplies to then create the base and create your Cape Canaveral of Mars, I suppose, to then create a rocket base and erect that rocket and then actually launch it. So
Eric's being really generous with this 10% number too. It's 10% of like just stuff. When you talk about like actual usable, like what's working in space, it's much less. So while 10% is like the dry mass aspects of it, like the amount, like your satellite, for example, is a lot less than a percentage of the overall rocket. So it's a difficult problem. I mean, you're 10 to 1 like pounds of thrust you need to put on first stages, for example. So
Yeah, that's why reusability, I'm going to go back to that. I'm going to keep harping on that with everybody in this room, that we really need a proper reusable solution to dramatically lower the cost. That's the only way this production line assembly works, the assembly line approach works really. I mean, really, it's the way any of these approaches work. So.
I want to throw a quick thought out there. Say, 200 years from now, we actually create this assembly line. We have all the infrastructure to go from Mars to launch, from Mars. I think Mars itself is actually a really, really perfect place to explore the rest of the solar system with. The reason is because Mars itself has a thinner atmosphere, so it's easier to get off of Mars than to get off of Earth. Also, the fact that it's closer to planets like Jupiter. Jupiter is actually really useful in the solar system because we do what's called gravity assist in order to propel that spacecraft really fast around the rest of the solar system. And since we're so close already, we can use that energy and basically, I don't remember the ratios, but you can usually get maybe double or even triple the amount of energy from your original rocket from just Jupiter gravity assist. Uses gravity to propel you somewhere else. So if somehow we managed to get a ton of humans settling on Mars and we terraformed it and it was a good place to go, it's a better place to be than Earth is, in my opinion, in the solar system.
Wow.
In terms of exploration opportunities.
We have another question ready from anyone. Cool. Yes. First question for you, Red. And you're number 2, right? Yeah. Okay. Please.
Well, I would just want to ask that is it more likely to, when we designed our space settlements, there are some of us designed it on the L4 and L5 Lagrange points, and those space settlements were designed to serve as a support for lunar bases. So I want to ask, is it more likely to first build up these midway stations and then by transporting goods from Earth and then to those midways and then from midways to lunar stations, or is it more likely that we first get to the moon and build up a station, and then we get back and build these midpoints?
Does everybody know what the Lagrange points are?
We should probably
give us 10 seconds. Yeah.
Lagrange points are stable points outside of Earth. So when you have two bodies that have a lot of mass, say the Earth and the Moon, you have these points that are located in between. There's a point in between the Earth and the Moon, completely outside the Earth and the Moon, where basically your spacecraft is stable there. You don't have to keep using propellant to try to keep yourself in a certain position. And so, as was described up here, there are great opportunities to create bases in those locations in order to know exactly where your spacecraft is going to stay and not have to keep correcting it and waste all the fuel. So that's a Lagrange point.
The answer to your question, I think, is absolutely. And before we go to Mars, we'll probably have like an outpost similar to what the space station is now at one of those points, or similar type areas that we'll use as a launching point to the next side. And that's really because there's no way we're going to be able to get like the amount of stuff we need to get to Mars, just on one shot from the Earth. We need to get out of the Earth's atmosphere, use all the energy, take most of the energy out of the equation that we need to get into orbit, and then work that aspect, and then build something up, and then go from there to the next standpoint. That's like, when I look at the future and the roadmap of actually doing this, I mean, this is maybe a little selfish way to think about it because I work at SpaceX, but I see SpaceX developing reusable rockets, and then other companies developing the modules that will actually inhabit this space, using those reusable rockets to create this outpost, and then creating some next generation craft within that area that then takes us to Mars.
So let me ask you a question. There's right now, Bigelow Aerospace is developing, everybody should check this out, developing inflatable structures in space. So right now, if I understand correctly, on the side of the International Space Station, is this a thing right now, or am I making this up? It will. It will. So Bigelow Aerospace, they have tested a inflatable spacecraft, like an inflatable room in space, to see if that's a way that we can have a space hotel or a space conference center to hold ISDC 2054, 60 miles that way. But where do you guys see that going, 30 years from now? Do you see the structures of being around the Earth? Do you see there being hotels there? Do you see this being a tourism place? Could we maybe be having this discussion in 30 years up there? Is that possible? What do you think those structures look like? And are these people going to be hanging out up there?
I'd like to think so.
I love the idea of it.
Yeah, I love the idea of it. We do need to solve that radiation thing, and so I love the inflatable structures. It's a brilliant idea. You get so much more volume for your mass. It's going to be inflated with a pressurized atmosphere anyway, so might as well use that for your advantage. But the walls on those things are only about a foot, and you're going to need a lot more stopping power between you and the harshness of space, the radiation environment, essentially, protected from space cancer.
Right.
But absolutely, and you can send 1, 2, 3 of those things out there maybe, and then just blow them up.
Bouncy castle in space is my dream. Any thoughts on structures floating above the Earth?
Even right now, all the spacecraft that were built, like for example, the Apollo lunar landers, some of those landers had sections that were only maybe a fraction of an inch, a few microns thick, and that was the only difference between being inside, an atmosphere that a human can stay inside and being outside in the vacuum of space. And so it's really not unprecedented already to come up with an idea where you're just going to have this big inflatable structure that's super lightweight and can theoretically absorb any micrometeorite impact by just kind of expanding outside, and closing up that hole, that sort of gap there. So I love the idea of inflatables. I think it's really the way to go in the future to create very large expanses of space. I know there's various problems you're going to run into. For example, a very large object like that in low Earth orbit is going to have a ton of drag, and so it's going to have to require a lot of propellant to keep raising it up higher and higher, and keep it into orbit. The ISS has that problem right now, is that it just takes a lot of fuel just to keep it where it is right now. But going out beyond low Earth orbit, it's pretty much the way to go. You're not going to be able to create a huge structure static on the ground, try to fit it into a fairing on a rocket, and then bring it up there. It has to be expanded somehow.
So why don't we take 2 more questions if there are any more questions remaining. 2. If you haven't asked a question yet, then you will have the priority, and we will go with this gentleman right here first. Could you stand up, please? Yeah.
Now, going back to transporting cargo from Earth to Mars and back from Mars to Earth, what do you think about using cannons or railguns for that?
So the fundamental problem with railguns right now are the accelerations that you incur in order to get going, basically. So you got to stop to basically orbital speed in a very, very short period of time. So you would literally flatten a human. Like we're 3D bodies, and we would do just paper.
Yeah, but for cargo, not for humans.
So surprisingly, human beings are pretty resilient, and it would take some pretty serious engineering and mass to make cargo also resilient enough to do railguns. It's definitely an interesting concept, and something that is worth continuing to explore. But you got to solve that fundamental problem of making things extremely, extremely strong and able to withstand those accelerations, basically the force that it takes that a railgun would put on your thing. I mean, your plastics, these things wouldn't survive. It wouldn't survive. The building wouldn't, the G's you're talking about are just too high.
Well, the question is, how big of a railgun do you really need in order to get to orbital speeds, right? Because you can create a really small railgun that, if you weren't worried about getting crushed, you would have a very quick speed. Once you leave the railgun, you're in what's called a ballistic trajectory. You're leaving, and there's nothing propelling you anymore. If you were to start on that ballistic trajectory too low in Earth's atmosphere, and even Mars' atmosphere for that matter, you're going to get so overheated just from the shock waves hitting you once you leave that railgun that you're probably not even going to get to orbit, even if you reach such as orbital speeds. You really have to, the way that rockets work is that they slowly climb up out of the atmosphere and then do most of their acceleration once they've left the majority of the atmosphere. So I can foresee maybe a huge railgun that is like, goes up maybe a mile or something. Creating that huge railgun and the power to support and everything is a really huge task. And maybe it can be done on Earth, in the future. Can it be done on Mars? Well, you'd have to get all that infrastructure to Mars in order to build it there, right? So
it'd be really cool.
It'd be awesome. I'd love it.
We're going to do one more question. We're going to take the question from the winner of the first day's 3D design competition. Right back here. Stand up. Last question. Go ahead.
Yeah. You told that almost everything that we send to space, the 10% comes back. 90% is fuel, almost. So what about using other power types such as fusion reactors, magnetic confinement fusion? They're self-sustaining, and I think they can bring the spaceships from here to Mars and Mars to Earth very easily. And it's a bright future, I think. So what are your plans in that type of power sources?
So you want to put a nuclear bomb on the back of a rocket?
No, actually not a nuclear bomb. Magnetic confinement fusion reactors, MCF, that tokamaks.
For the record, it's been done and attempted, and it didn't go along well in terms of politically. But go ahead, why don't you go?
I'm actually not. I'm going to listen to Eric because I'm not that smart. I know that it was basically putting a nuke on the bottom of the rocket.
Well, one of the big ideas of going from low Earth orbit